So now coming to the function analysis, yesterday we saw that there are three stages of function analysis. First stage is component analysis, then we do interaction analysis, and then finally we do the function modeling. In component analysis, what did we do? In component analysis, we identified the components of the engineering system and its super system. So what is the difference between engineering system and super system?
Super system includes all the other things in the environment that interact with the engineering system.
And engineering system is?
Just the machine part in the super system. Like
engineering system is the system on which you are working. When you call it a machine, you make it sound very mechanical, Soumyadeep. There was already a concern कि ये चीज algorithms पे और computers के लिए software के लिए valid है कि नहीं है. So don't call this word a machine. Engineering system is already a very loaded term. Okay. So yes, engineering system is the system that which we are working on, and super system is the context in which it operates. So all the things that my engineering system interacts with, is touching, is dealing with, would become a part of super system. For example, if it's a computer program, then the user who gives the inputs, the user who receives the output, the printer and other stuff could be super system components. Whereas the program itself, the algorithm of the program itself could be your engineering system. Interaction analysis, we looked at the interaction analysis then, and we also looked at a tool called interaction matrix to list down that interaction analysis. Where what we said was, wherever there is a touch happening between two different components, only in those places there is possibility of a function. So we said that we will put a plus sign in all those boxes where there is a interaction happening, a touch happening, and put a minus sign elsewhere. Then we came to the stage of function modeling. In function modeling, we said that it identifies and evaluates functions performed by the components. So functions performed by components, we looked at some aspects of it. We said that there are a few mandatory conditions for function to exist. The first condition is that both the function carrier and the object of the function are components of the system. Now, these components could be either substances or fields. What is the difference between substances and fields? What was it that we discussed yesterday?
Have rest mass and do not have rest mass.
Yes, the substances have a rest mass, fields do not have a rest mass. Fields could be fields like magnetic, electrical, acoustic, mechanical, fields like gravity, and so on. And substances are objects with the rest mass. Then we said that the second thing is, the second requirement, mandatory requirement for a function to exist is that the function carrier must interact with the object of the function. There has to be some touch happening. And then the third thing we said was that some parameter of the object should change or possibly simply maintained. Maintained is also a change, because if that function was not happening, then due to entropy, something would change. So we are acting against entropy. So even maintenance of some parameter could be the result of that interaction that is happening between the function carrier and the object of the function. And then we looked at some examples of what kind of functions there are. So we also looked at that there is no function that an open door is doing. Why? Why is there no function that an open door is doing?
Because it is an object and there is no interaction between that a girl entering the door and the open door.
Yes, because an open door does not interact, it does not touch the object of the function. If you say that you would let a person pass, the open door doesn't touch the person. Huh? So there is no function that an open door has. We also said that we will not use any negative formulations. We said that we will not use declarative formulations. What were the kind of declarative formulations we looked at yesterday?
So cleaning, like tooth cleaning, basically.
It cleans, the brush cleans the teeth.
Protection from helmet.
We will not use the terms like clean, protect, safety, all these things, which as engineers, you cannot really do much about. As an engineer, you need to understand what needs to be done, what parameter needs to be changed. So we need to be as specific as is possible for us. And if we can't really think of a good verb, let us simply use the thing like, the function carrier changes y parameter of the object of the function. So function carrier hammer changes the position of the nail. So instead of like, if we do not want to use the word hammer moves the nail, we can say hammer changes the position of the nail. And then we also discussed that we will document only consequential functions. We will not document inconsequential functions. And which functions are consequential can depend on which system, which context they are operating in. We took the example of coffee. We said that typically air cools coffee is a function of consequence, and that coffee heats air is not a function of consequence. However, if you were the one who was designing the air conditioning of that barista cafe or the cafe coffee day, then how many customers are there and how many hot coffees are being sold is a parameter of interest to you, because that coffee would be heating the air, and that air, the primary function of your engineering system is to cool the air. So this, in this context, coffee heats air also becomes a consequential function. In fact, air cools coffee is inconsequential in that context. Are you able to see this?
Yes.
So now we move a little further. What we are now saying is, in this diagram, is that any component of a system can be both a function carrier and also object of functions. So it could be function carrier, for example, for function 1 and function 2, but it is an object of function for function 4. This particular component is object of function in function 3, but is a function carrier for function 4. What we are also saying is that any component could be performing more than one function in any engineering system. Is it okay? Let's look at an example. What do you think is the main function of this car? So there is one main function of any engineering system. So what is the main function of this car?
Traveling.
Transportation. Traveling. Solving.
Let us use the language of functions. Let us use the language of functions.
Sir, to move from one place to another.
To move itself.
People.
Yes. Transport people.
So the main function of the car is to move passengers and cargo. The car moves passengers and cargo. You can also load luggage into it and it would move luggage also, nahin? So whenever we start to do function modeling, the first thing to do is identify what is the main function of the car, of the engineering system. Now, the object of the main function is typically a part of the super system. And it is called as target. So in context of the car, the main function is moving passengers and cargo. So passengers and cargo, do you realize both are targets? Both are outside the system? Both are not a part of the car? and both of them will be called as targets. They are super system components and they will be called as targets. Okay. Now there could be other super system components also, which could be there. For example, road. The car moves on the road. So the wheels of the car, for example, would rub against the road and therefore the car would move forward. Am I right?
Yes.
So road is a super system component, and there are some components in the engineering system which are interacting with the road. So there is some function from the system to the super system, but clearly there is some function from the system to the target. And this function is called the main function. When we do any modifications in our engineering system, we cannot remove the target, because that was the main reason why the engineering system existed in the first place. Are you able to see this? We'll look at a few examples and this will become more clear. But let's just understand that this is pretty evident that if an engineering system exists for a particular purpose, that purpose is the main function of the engineering system, then the target of that main function cannot really be removed from existence. It will be there. And whatever else we do with the engineering system to improvise it, the target should get its main function still resolved. Whether component 18 does that main function, or I reassign and repurpose component 1 so that component 1 does that function, that is a different thing. But the main function cannot be deleted from a system, because that is the primary reason why the system existed. Now, what we are saying is that once we have identified the target, we should know what parameters of the target are also changing as a result of the main function. First, main function cannot be removed. Then we should understand what is the desired change in parameters, and then we should try to enhance it. For whatever projects you are choosing to work on, once you know the target, you know what the main parameter is, and then you can work to improve the performance of that function. Okay.